Hello, I'm Laura Merritt and Council Member of OCCA. I would like to welcome you to OCCA's weekly webinar. Thank you for joining us. I'd also like to thank 3M and Lawrence Industries for today's presentation on innovative paints and coating solutions enabled by glass bubbles. I think this is going to be a really interesting talk, and it's my absolute pleasure to be hosting today. The presentation will begin in a few minutes and the slides and webinar will be available to you, so you don't need to make notes. However, what I'd like you to do is ask all your questions at the tab at the bottom of your screen, and we will answer those at the end of the presentation. OCCA, as you know, is a professional association for the coatings and allied sectors. We're headquartered in the UK and we have members all around the world. Our membership is inclusive. We welcome people from technical, commercial and operations from our industries. We have 3 types of membership, ordinary, professional and student. All the details of these are on our website. We were established to assist with the education and training of individuals within our coatings and allied industries and promote links between academia and industry. We offer bursaries to help promote further education, and we arrange webinars, seminars, networking and social events at all local and national levels. But not forgetting, we are a charity and run by volunteers. Now, many of you know I'm the current head of the Surfex exhibition. This is the UK Coatings exhibition. It's a 2-day event which is occurring next year on the 4th and 5th of June in the Coventry building, in the Coventry arena even. We are expecting an excellent exhibition. Exhibitors come from raw materials, equipment suppliers, distributors, formulators and manufacturers. We are planning workshops, industry-led lecture sessions, technical seminars, all from industry experts and universities. Our last exhibition in 2022 was a tremendous success. It was very well attended. We had a very high profile visitor attendance, and at the moment we do still have some positions left on the floor plan. So please get in touch with STEP for more details if you would like to exhibit. If you are a member of OCCA, one of the benefits is you get our Surface Coatings International Journal. That contains industry news, technical papers, regulatory news, product showcases and details of industry events. Now, we're very lucky. OCCA has good corporate sponsors, one of which is talking today, which is Lawrence Industries. If you'd like to become a corporate sponsor, do get in touch. You would be amongst very good company, and there's a whole raft of benefits available to you. We also have partnerships with the universities where members will go in and talk to students about our industry and the opportunities and careers available to them. I would like to introduce Dr. Friedrich Wolff of 3M and also Ian Brown from Lawrence Industries, who distribute for 3M. Friedrich is an application engineer at 3M Advanced Materials Division in the EMEA. In this position, he supports customers in developing innovative products and applications based on hollow glass microspheres, which are the 3M glass bubbles. Before joining 3M in 2013, Friedrich studied material science and engineering, and he holds a PhD from the University of Erlangen in Germany. Over to you, Friedrich.
Yeah, thank you, Laura. And thank you for giving me the opportunity to give this presentation today. Thanks also to Lawrence Industries, our partner in the UK, who helped us to organize all this. Today I'm going to talk about paints and coatings solutions that use our 3M glass bubbles, and basically the goal is to make some innovative products that meet the targets, the challenges of our days right now. And before going into the examples of where the bubbles can be used, I'd like to briefly introduce this product. So we call them glass bubbles. In fact, these are hollow glass microspheres. So, and you can really break it down to three main characteristics. So, which is they are hollow here, like shown in this schematic here. Perfectly round spheres, one single void with a thin shell of glass. So, and with these characteristics, they come up with several benefits that we can use in different applications. So first of all, that's lightweighting because they're hollow. Hollow also means they are thermally insulating, and they are also have a white appearance. Despite the glass is transparent, the spheres always appear white because of the different refraction index of the void and the glass. Then their bubbles are perfectly round spheres, which means they have a low specific surface area, which means low oil absorption. And that means at a constant volume concentration, we have a lower viscosity, which on the other hand allows us to formulate with pretty high solid contents in terms of volumes. So we can formulate for very low shrinkage. And last, as I said, they are made of glass. It's a true glass. So a high quality borosilicate glass that we are using for our products. So purely inorganic. It's non-porous. So non-porous means the shell is dense. So no liquids can migrate from outside into the void. So no water uptake is possible here if the bubbles are not damaged. And it's really a true glass, borosilicate glass that is chemically very stable, not soluble in water or anything like that. I'm mentioning that because there are hollow glass microspheres in the market that are water soluble. So therefore, that's a really differentiator from our products here. So in their paints and coatings and construction area, we are addressing different benefits, and the most important ones are outlined here. So first of all, what I called build more with less. So basically, this comes back to lightweight construction, lightweight design. So, and this is all about sustainability finally, because in the end, our resources are limited, and it's not all about energy, but also we need to be careful about other resources, on materials, on raw materials that we use. And with since the bubbles have a low density, they come up with a high volume, so you have high yield, and you need less material in terms of weight that is actually used. Then lots of our products, or the products where glass bubbles are used, are addressing thermal insulation, Then others are addressing solar heat reflectivity for coatings, can be for facades or roof coatings, and I will talk a little bit about that later. Then it's always about products that are easy to apply, good workability, and finally, it's about the quality of the products. So long-lasting products that also help to preserve the buildings where they are used. There's not just one glass bubble, so we have a pretty large portfolio of different grades. And this slide on this diagram is showing not all of them, but quite a lot. And here you can see each of these circles is representing one grade of glass bubble. And they are differentiated in terms of density, which is here plotted on the x-axis. And when we talk about density, we always mean true density, which we measure in a gas pygnometer. So it's not the bulk density, it's really the true density. And then their next important characteristics is the strength of the bubbles. We specify our glass bubbles in terms of isostatic collapse strength. So isostatic pressure is applied, and then we determine which pressure the bubbles can withstand before 20 or 10% of them break. And the last characteristic actually is the size of the bubbles. So that's here, that these are the numbers that you can see here in the circles. That's always the D50, so the medium diameter in micrometers. So, and you can see that there is, of course, a trend. So if we go to higher densities, then the bubbles become smaller, but also stronger. So or the other way around, the lower the density of the bubbles is, the larger they get, but also the more fragile. Then we have some grades which we developed in the recent years or the last decade, let's say, which are differentiated by a very high strength to density ratio. So these are made in a somewhat modified manufacturing technology, and you can see they come with a smaller particle size, but they are significantly stronger at the same density or offer a lower density at the same strength. So, and strength is very important if we have to find out which is the best product for your application. So very often customers are looking for a very low density product. So we want to go as far to the left as possible, but we always have to consider and think about what is the strength we need in order to survive mixing processes, application processes, and also to perform during the lifetime of the final product. And that's basically where I come into play, and of course also our partners like Lawrence in the UK. We are always there to support you individually to discuss what is the best product for your application. And with having said this, I would like to go to the applications section and a little bit talk about where we can use glass bubbles and what benefits they can bring to different applications. And I would like to start with paints for the exterior, which can be like paints for facade or roof coating or similar. So, and there we find glass bubbles in paints for solar that provide solar heat reflectivity. Why is that important? This diagram is showing the spectrum, solar spectrum of the sun. And we can see that about half of the irradiation from the sun is in the near infrared range, which means we cannot see it, but it heats up our houses or buildings or caravans or whatever. So the goal is to reflect as much of this irradiation in order to prevent massive heat up of buildings or other objects. So, and in the next slides, I would like to show you what glass bubbles can do to improve reflectivity of paints. And for that, we did a small study starting with a very simple paint formulation. And here for this paint, basically everything was kept constant. Water, binder, all the additives, titanium dioxide. And we always used the same amount of filler in terms of volume. But we used different fillers. So for prepared different paints with different fillers. And as a reference, we used calcium carbonate. And then we used different kinds of glass bubbles, always the same volume. But you can already see in terms of weight, it's a significant difference because of the lower density. And by the way, this also has a significant impact on the wet paint density, which is reduced here by approximately 30%. And so now we then in the next step, we compare the performance of these different paints with respect to solar heat reflectivity. So first of all, we had a look at the paints in a photospectrometer. So we measured these spectra, and here for the ease of reading and understanding this slide, I just plotted two lines. One is the reference with the calcium carbonate, and the other one, the red one, that's the paint with our bubble grade S32HS. And you can see that the reflection value is higher basically over the whole range here in the visible, but mainly in the near infrared range. We have a higher reflectivity compared to the reference paint formulation. And that from these spectra, you can calculate the TSR, total solar heat reflectance. And we see that for all the glass bubble formulations, this is higher compared to the reference with the calcium carbonate. And this is mainly coming here from the portion that goes back to the infrared, near infrared range. That's the same values, but here plotted in the diagram, it's a little bit easier to read. So we see here about TSR value, about 91% for the calcium carbonate, and higher for all of the glass bubble grades. And we also see that here some of the grades that are based on this modified manufacturing technology, they show their even better performance. And this is all about the smaller particle size. So smaller particle size is beneficial to get a higher TSR value. And now you may ask the question, is this significant increase from 91% to 94%? Doesn't sound a lot. And yes, it is significant, because you have to imagine that we have irradiation of 100% here from the sun. And in case of the standard paint, 91% is reflected and the remaining 9% is absorbed and transferred into heat. Here, if we have a reflectivity of 94%, only 6% are absorbed and transferred into heat. So that means that's 1/3 better. And to show you what effect this will have in a real application, we installed this very simple test setup. Actually, it's an infrared lamp, and then we prepared aluminum panels that were coated with their different paint formulations. And then on the back side of this panel, we have a thermocouple with a data logger. And then after switching on the infrared lamp, we were logging the temperature. And you can see that for the reference with the calcium carbonate, here we finally found a temperature of about 60 degrees C in the steady state. And for all formulations with the glass bubbles, it was lower. And we found the best performance here with the S28HS and the S32HS. And that's exactly the grades that also showed the highest TSR value in the spectrometer. So with having said this, I would like to a little bit move to a few other benefits that we also see in the paints, and which are also very important, particularly for exterior applications. And that's about crack susceptibility and also crack bridging properties. Formulations with bubbles often have good crack bridging properties, which is very important for like renovation jobs, but also for new materials. We have the problem or the challenge that if we work, for instance, with insulating bricks, the masonry nowadays is not as stiff as it was in the past. So there is more movement, and therefore also the plaster, the stucco, and everything that is applied on the facade needs to have a lower modulus in order to prevent cracks. So if you don't decrease the modulus of these products on the facade, then you get a lot of stress in the paint, for instance, or also in a plaster, and you have a high crack susceptibility. The bubbles will decrease the modulus. So that means if there's some movement in the facade, the stresses are lower, and stress is also dissipated, and they're less prone to form micro cracks. And why is that important? Because these cracks, micro cracks, are typically the beginning of evil, like formation of algae growth. And if we can avoid cracks, we also avoid other problems that can arise from that later on. And last not least, what's also very important is the moisture management. It was shown in several studies and experiments that glass bubbles can help to formulate paints with very good water vapor transmission properties, so low SD values, while it was still possible to have good liquid water barriers at the same time. And that's important to get the facades protected and also to keep the masonry in the insulation dry, because the vapor can move through the coating, through the paint. That will eventually preserve the building structure and also help to have a healthy living climate inside your home. So with that, I want to step inside and talk a little bit about applications for interior paints and the benefits glass bubbles can bring in this application. So here we find bubbles in products that are marketed for thermal insulation or low effusivity comfort paints. I'm talking about that in a minute, what that actually is. Thermal insulation, I think that's pretty clear. We see here that if we formulate paints with higher contents of glass bubbles, so you see here also the PVC is increasing, we can get very, very low thermal conductivities for paint. So down to about 0.1 watt per meter Kelvin. And of course, paint that is applied only in very thin layers is not replacing their insulation of a house. It's by far too thin, but it can provide some benefits, such as higher wall temperatures, and also something what we call low effusivity. Effusivity, actually, that is a little word formula, which is the square root of thermal conductivity multiplied with density and the heat capacity. And actually, this is the value that defines if a material feels warm or cool. So that's the reason why in winter, like concrete feels cold and wood feels warm. That's thermal effusivity. And glass bubbles, so they, in the formulation, they decreased their thermal conductivity, they decreased the density, and which gives us low heat capacity as well, and therefore low effusivity. So it's a warm touch. So if you touch a wall painted with glass bubble paint, it feels warm, feels warmer. And also, if you measure with really the temperature, due to the insulation effect, the wall temperature can be a little warmer, not just 1 degree C, maybe 2. And why is that important? It's about comfort. And there is already more than 70 years ago, there was Bedford published a so-called comfort model, where he talked about a relationship between the wall temperature and the air temperature, and where most people feel comfortable. So that's here, this area, which is marked yellow. And what we can see here, like, let's say we have a wall temperature of 16 degrees C, then we need like 20 degrees C in the room to feel comfortable. If we can increase the wall temperature, for instance, with such a paint, then we feel comfortable also at lower air temperatures. So first of all, that's a comfort thing. And then, of course, this allows us to lower the air temperature in the room. So turn down the heater and still don't start to freeze, still feel comfortable. And there's a rule of thumb that each degree C lower room temperature makes about like 6% of energy saving for the heating. So therefore, that can be very interesting. And there's another thing where higher wall temperatures are very interesting and very important. That is to reduce condensation. For instance, in rooms where you have high humidity, like in a kitchen or in a bathroom, where condensation can be a problem, and from that, mold formation. And that's what I want to talk here about. Like, that could be such a room, and here you see under the ceiling, you have a cold bridge, for instance, you get condensation and a mold formation. And in the next slide, I want to show you how glass bubbles can help to retard the condensation here. That's a test setup we built in one of our labs, and it basically consists of a fish tank, or empty fish tank here. And in this fish tank, we have here some salts that generate a high humidity. And we have also in this tank a cold box. This cold box was built of EPS boards, and it is cooled with a Peltier cooling system, actually just taken from a camping box. And there are some windows in this cold box, which you cannot see right now. And in front of these windows in the insulation, we installed the samples. And the samples are actually, again, aluminum panels here in the form of this arrow. And these panels are again coated with different paints with different formulations. So that means the samples are in an atmosphere of high humidity, and there's a cooling from the back. And then we watched until condensation forms. First drops are formed and finally drop off. And we measured the time until that happens. And here, that's an example. There was a standard paint where this, the first drop was formed after 24 minutes, and a paint that contained the glass bubbles, then it appeared only after 41 minutes. So still there will be condensation, but it can be retarded significantly. So that gives you the chance to open the window in the bathroom and get rid of the moisture, for instance. So after talking about our paints for quite a while, I now briefly want to switch over to speckles and wall fillers. So go to a little bit thicker coatings. And here we can make benefit of what I mentioned previously. That is the perfectly round spheres of the glass bubbles, which allow to formulate with very high volume fillings. So we can have volume fillings like up to 60% by volume. And that actually allows to formulate materials that have virtually zero shrinkage. but are still workable. So you can apply such a, like here, like a wall filler that does not shrink, therefore also does not form any cracks, like here this example that was here in a standard formulation only without bubbles, so basically only calcium carbonate. And yeah, so there's not a lot of, or you don't need to rework again. It's also easy sanding because of the bubbles. You can even drive nails and screws in such a material without cracking. And yeah, finally, it is very easy to apply, and yeah, because of no reworking needed or less rework needed, it's yeah, time efficient and finally saving labor cost. And it can, so here the glass bubbles can be applied in like wall fillers like shown here, but also in yeah, in like airless speckles that are applied to really larger areas. And here we have products like the S28HS, which are strong enough to survive the pressures that we see in airless spraying. So this specific product, for instance, can stand more than 200 bars of pressure. So, and even, yeah, after the high pressure spraying with the airless gun, the bubbles do not break. And the last example I want to show you is now yeah, from the industrial range. So we are not only in the architectural paints, but also industrial. And I'd like to highlight one example for industrial insulation. And that's what often is referred as thermal protective coatings. So we do insulation, of course, because for yeah, energy savings, but it's not only about energy saving, it's also about safety. So safety regulation tells us that, yeah, hot surfaces have to be protected, to be touched. So either you insulate them or you build around a housing or anything like that. And both can be costly and sometimes not very practical, because yeah, you need to work on that. Your housing would make everything difficult. You cannot, there's a lot of maintenance, for instance, and then you always have to disassemble it. So, and here's our coatings that are highly filled with bubbles with a high solid content, and which are applied in a few millimeters thickness, can be interesting to decrease the surface temperature below this, yeah, typically 60 degrees C. So therefore, you don't need housing or additional insulation anymore. Again, with using the right bubbles, such coatings can also be applied by airless spraying, and there's the benefit that yeah, it can easily be repaired. So, for instance, if you have maintenance, like at a Wolff or whatever, you scratch off the coating, and afterwards you just repair the coating after you exchange the valve, for instance. And last not least, since this coating is directly applied on the pipes, on the valves, whatever, there is, in case of yeah, condensation effects, there's no water can accumulate under the insulation, and therefore it's prevents what is typically referred as corrosion under insulation, because there's just no gap between. So with that, brief overview, I'd like to stop for today. I thank you for your attention, and I'm happy to answer your questions.
Thank you, Friedrich. That was really interesting. There's been a couple of questions in, so anybody who's got any questions they'd like to ask, please look at the menu at the bottom of the screen and fill in your questions on the Q&A. I've got one question myself. You've shown spray coating using the glass bubbles. Can you apply your paints with glass bubbles in?
Absolutely. You can brush, you can roll. So there's no limitation to that. So typically the most demanding ones are the spraying, particularly the LS spraying, as very high pressures are applied there. And but if we use strong enough bubbles, that's also feasible. And if it's just applied by brush or by roll, then of course we can use also other grades.
And when you've got your pot of paint with your glass bubbles in and you've left it on the shelf for, let's say, 6 months, do you get settling? I've got a vision that the glass bubbles all rise to the top, and then you're going to be stirring them in and maybe destroying your glass bubbles. How does that work, Friedrich?
So the bubbles are light, very low in density, so therefore they always have the tendency to float in a low viscous system. Basically same as some conventional high density fillers are settling down. So it's the same, more or less the same challenge in a formulation. We need dispersing agents that keep the bubbles dispersed and guarantee also the shelf life of a coating.
Perfect. Okay, let's go through some of the live questions. Sumit Ahuja, he's asked about formulations. We'll provide some for interior and exterior crack filling. We'll do that afterwards. I don't think you want to give out formulations at the moment. Ruz Gonzalez asked about distribution of products in Latin America, specifically Uruguay. Again, Lawrence will get in touch with you, Ruz, for that one. Neil Rogers, some modern emulsion polymers are engineered to have very small average particle size, some as small as 50 to 60 nanometers. Do you have any experience evaluating emulsion polymers of varying particle size with glass bubbles, and what is the expected impact on solar reflectivity in an exterior paint?
Mm-hmm. I think this is referring to their nanoparticles that are on the one hand colored, so really bringing color, and also this solar heat reflectivity. This actually can be combined, because the bubbles are white, so therefore what I just showed, that's actually for white formulation. Right. But if you really want to bring some color in, and particularly dark colors, then these nanoparticles are very efficient. And we did some trials in combination in the past. So there's some data available, and I think that's something that can be discussed individually.
Okay, Helene Di Marcantonio, for a cool roof paint, which grade do you recommend for airless application for a 150 nanometer dry film thickness? What percentage by weight or volume? So answering the grade, so
if it's about airless spraying, then the S28HS is probably the right one, because it is definitely strong enough to survive this application. With others, we really have to be careful about the pressure and look into that very in detail. But S28HS is surely a great product for airless spraying and also solar heat reflectivity. In terms of the amount, that really is difficult to answer in general, because it really depends on the whole formulation.
Yeah.
So maybe, we have to go in there into the formulation individually, but generally we need quite some volume. But due to the low density, this would be, in terms of weight, maybe 3-4% by weight, roughly. It also depends, on really on the formulation, also actually on the grade and so on.
So a question from Nand Hakuma: what about safety in terms of handling these?
Our glass bubbles are safe to handle. They are likely to form some dust, or because they are lightweight. So therefore, we always have to make sure that we create as less dust as possible. So that's also where we can help with recommendations for handling. Of course, if there's dust, we recommend to wear respirators. But what is also very important, the bubbles are large enough so they cannot enter into the lung. So even if you inhale some, it's not very comfortable, but it's not dangerous.
Yeah, they're not toxic, aren't they? So,
yeah, correct.
From Dilip Jetho, will the presentation be shared? Yes, it will. we will tidy it up and send it on to you in the next day or so. Richard D'Souza: what is the optimum levels for surface tolerant mastics?
Again, I think difficult to answer in general. I think that needs some individual discussion about the formulation. Yeah.
Perfect.
So therefore, everyone, please always feel free to reach out to us at 3M, or to Lawrence or other distribution partners, and we all will be very happy to help you on that.
Perfect. Richard, the team will be in touch with you. From Sivasambu Boehm: thermal conductivity is low, and have you considered to combine other materials to make a hybrid system?
Not sure what is meant with a hybrid system.
No.
Yeah, or with some other lightweight fillers or some others. So probably, of course, it's very often it's combination. It's a combination of of fillers. Also, what I showed in the paint formulation, that was let's say the extremes where I replaced all of the calcium carbonate with the glass bubbles. In a real formulation, typically it's a combination. We are not replacing everything, but it's a partial replacement. So there is still some calcium carbonate for different reasons, and the same is also for other benefits. Very often it's combined with other fillers. Can be lightweight, but can also be high density fillers to optimize the properties.
From Bruno Ragua Jean: for a cool roof effect, what is the best grade, and what about the quantity to have a high SRI?
Mm-hmm. Yeah, again, here, small particle size is very important for that. And so therefore the S28HS, as mentioned before, is very good for that, particularly if it's for air spraying, if it's only applied by brush or roll. Also the S22 can be interesting. And maybe as a small outlook for the future, we are also constantly working on new products, and maybe there's, or hopefully there's pretty soon something that will also be very interesting for this application.
Okay, Richard D'Souza again, he would like to know, he was the one who asked about the mastics. He would like to know about thermal insulation coatings. So I guess coming away from paints then. Yeah,
but thermal insulation coatings, definitely. That's where we can use the bubbles. And also the bubbles, actually, they don't care about the matrix system. Yeah, is it just a dispersion system, or is it a resin system like a epoxy or polyurethane system, or even cement based systems? So I wasn't talking about that today, but we have systems for stucco where the bubbles are used in cement based dry mortar systems, and where we can go to really also thick layers for thermal insulation. So yeah, there's no limitation to that.
Perfect. Zain Benares, yes, we will send you the presentation once we tidied it up a little bit for you. Marcia Raduluscu, what about the film's thickness and what about drying time? I think you've mentioned a couple of different thicknesses.
Yeah, I mean, that's the film thickness that you apply, that's basically up to you, and depends, of course, on what you want to do, what you want to achieve. But they're like the last thing I was showing for the industrial insulation coatings. So these are typically a few millimeters. Of course, architectural paint is much thinner. So it's it's really up to the application and also up to the formulation.
We've got a question that Ian would like to answer. This is from Leonard Diedrichs, who is the supplier in Cape Town in South Africa. I think Ian Brown would be the best one to get in touch for that.
I think so. If Leonard could get in touch with myself, then I can direct him to the correct distribution partner in South Africa.
Perfect. Thank you very much, Ian. Another question from Helen Skelton. At what stage in a coating formulation do you add the glass bubbles? Do they withstand milling conditions when making paint?
Very good question. Thanks. That's very important. We recommend to add glass bubbles as late as possible. So basically to the let down. So please don't add the glass bubbles during the milling step. So because then there is a high risk that you break a portion of them, maybe not all, but a portion of them. And so please add them at the let down as late as possible, and don't be afraid. So the glass bubbles get dispersed very easily, so they don't require high shear as pigments need. So it's really like basically with a little bit of stirring you can mix them. But please not to the milling. Thanks.
We've got another anonymous question about safety in terms of handling. Friedrich has spoken that they're non-toxic. It may be an issue with powder that's associated with the glass. I think that covers that one. Benita Urabam, does it impact other paint properties?
I think always everything you do on a formulation has impact on some other properties, and therefore I think that comes a little bit down to the question we had before about combination with other fillers. So that's the reason why in an actual application, typically it will be combined. There will still be calcium carbonate or other fillers in a paint to ensure that opacity is high enough, scrub resistance, and all these properties. Yeah, I always say the glass bubbles are just another part in the toolbox of a formulator. So it's always a combination of other fillers and also with the additives and so on.
Perfect. From Klaus Stroll, have you carried out any total solar reflectance tests in clear coatings?
I don't think so. I'm not sure, but I need to dig into my data. But right now, I'm not aware of it. But of course, we can do it. So if he wants to reach out to us, maybe we can do something together.
Perfect. Again, from Helene Di Marcantonio, is S28SS shear stable during dispersions? Is a specific dispenser needed?
So typically the S28HS, it's a very stable bubble. So I'm pretty sure it will survive most of the applications here in the paints and coatings. I think we can definitely again discuss individually about the setup and shear forces and pressures that may apply, but I'm pretty confident that it would be a good product. Yeah, it would survive.
Perfect. Right, I think we've come to the end of our questions at the moment. If you wouldn't mind hanging on, Friedrich, just in case we get a last minute one, I'd like to thank you very much, and 3M and Lawrence Industries and Ian Brown today. You've been brilliant. So you've got 1 more minute. If you've got any more questions for Friedrich, please send it through the question and answers. And while we're waiting for your last questions, so we are now in our 10th series of the OCCA webinars. If you become a member of OCCA, you have access to 93 webinars on all different subjects related to the coatings industry. And we have massive numbers of attendance, massive numbers of registrations. So we know our webinars are of interest. If there's a topic you would like for us to cover, please let us know. Keep an eye on the website, keep an eye on our social media, because we do promote our future webinars that are coming up. Next week, we have indestructible paints with a case study in the development of chrome-free diffusion coatings. After that, we have ink events. We don't have the title there. I've got the title hot off the press. That is where styling drives safety, Rheolite for increased safety and LiDAR visibility. So they will be along on the 12th. On the 19th, we've got Lanchem, bio-based dispersing agents for sustainable coatings, followed by Bic Gardner on the 26th of July. I'd like a quick reminder, this year OCCA have got the CIRCON conference. It's being held on the 21st and the 22nd of November at Warwick University, one of our partners. We have a call for papers. If you have a title, if you're a student, a technologist, out in industry, it's a 2-day event. We'd be very pleased to receive your application. We are fast approaching the closing date. That is this Friday, people. So get moving. And if you want to get in touch, please do so through the OCA website. We're on Facebook, LinkedIn, Twitter, Instagram. Do get in touch. We'd be pleased to hear from you. And we're happy to forward on any of your inquiries to Lawrence Industries and to Friedrich. We've got one last thing. Kevin Rink would like to say great presentation to you, Friedrich. So thank you so much for your time today. Brilliant presentation, absolutely interesting. I've got some more questions I'll ask you later.
Okay.
Thank you very much for your time.
Welcome. Thank you.
Thank you. Bye-bye.